Hello boys and girls, a very good evening and welcome to this live session on geometry for your upcoming SSC CGL Tier 1 exam brought to you by Talent Sprint. You are just a week away from the first lot of the SSC CGL Tier 1 exam, right? You all must be aware that the exam is scheduled to start from the 4th of August. I'm sure all of you have already checked your examination details like the date of exam, the time slot, etc. right? And then as you all know, 1 week before the exam you will be getting your admit cards as well. So hope all of you have strategized your preparation for the remaining days. It could be 1 week or 15 to 20 days depending on your date of examination, right? However, irrespective of the number of days left, you should be fully ready to take the exam now, right? Which I've been telling you over the last couple of weeks, right? Don't assume that if your examination is in the first lot you have a disadvantage, or don't believe that you have got a great advantage if you have got the exam on the last lot. These are all misbeliefs in my view, right? I would ideally want my exam to happen in the first slot itself so that I can just live peacefully after that, right? We all feel that if the exam, if our exam is in the later slots, we will get to know some insights from the people who have already taken it and prepare accordingly, which in my view is not the right strategy, right? I mean, that purely depends on your luck. So don't strategize based on luck or hope, right? Hope cannot be a strategy, right? Hope cannot be a strategy. So I think you should be fully ready now. You must have learned all the topics across all the subjects. You should have also practiced enough by now. But then, yeah, practice will only help you reduce your imperfections. So the more you practice, the easier it gets. So keep practicing for a few more days. But 1 day before the exam, you should just cut it down, right? Cut down your preparation, practice fully, and start relaxing. All right. So I think just keep that in mind. Also, ensure that you eat healthy, you sleep healthy in these last few days, so that these external factors should not hamper your performance. Yeah. And I hope that all of you are in good health already. All right. So I think these are the few points that I would like to mention, and like I said, all of you should know your date of examination by now already. So how is your preparation, and how prepared are you for this exam? How confident are you? You must be fully prepared, but how confident are you? Remember, it's not a test of your knowledge. It's not just a test of your knowledge. It's more to do with your state of mind, right? It's a test of your behavior, right? They are trying to see if you can handle that pressure, if you can work under pressure. So practicing alone is not going to help it. Practicing more and more questions or learning shortcut formulae is not going to be enough, right? You have to do something more than that. You have to learn how to control your emotions. You have to keep yourselves calm and composed during the exam, because those 60 minutes are going to change your life, right? So make sure that you also practice the other side of it and not just the questions, so that you can boost your chances of selection. Okay. Now, for the benefit of those who have recently enrolled in our program, let me mention that there is a chat box available right beside your video screen, which you can use to interact with us during the session. So please use that chat box and tell me now about your confidence level for the SSC CGL Tier 1 exam, which is going to start on the 4th of August. I can see a lot of you have joined the chat already, and Amit Kumar says he's fully confident and he needs luck in general GS section. Well, I think general studies section, right? Well, good. I am glad to see that, know that you're fully confident for this exam, and don't depend on luck. What would happen out of 25 questions in general awareness or general studies? You may answer only 5. Doesn't matter. If you're strong in the other sections, I'm sure you will still stand a chance to get a call for the next round, right? Nayan also says all depends on general studies. The score varies. Yeah. Neeraj says the background is different. Yeah, the background is different. It's not white today. I hope that helps you score more in the exam, if by any chance that can happen. Pravesh says no confidence. What happened, Pravesh? Why are you not confident? Then Sumit also says except GS all is well. Yeah. Murli Krishna says what will be the cutoff? Murli Krishna, I hope I know the answer to this question, right? Nobody on the planet knows what the cutoff would be, right? Even the paper setter would not know what the cutoff is going to be, because that's not in your hands, right? It's not in your control. That cutoff score is something which is decided after the examination gets over. So don't worry about that. I think these questions that you have in your mind about the cutoff score or the type of questions that will come in the exam, minimum number of questions that I should answer. All these things will add to your nervousness, which is very risky, right? Little bit of nervousness is natural, but you cannot let it build on and hamper your performance. So don't worry about all these things. What is in your control is your preparation, your performance. So just focus on that. Yeah. Praveen Pugh says weakness is math, or weakest is math. Well, I am actually disappointed to find that your weakness is in the math section, because in my view that's the easiest section, right? You can easily score more marks in mathematics if you are strong in your calculations. Never mind, I think whatever time you have for your exam now, just focus more on maths and I'm sure you should be able to do well. Neeraj Jha says, although I've started late, but I'm feeling a lot of confidence that I can give my best. Yeah, I think you should just give your best and come back. Genome has mentioned that geometry part will be skipped. Others, somehow I'm confident. Yeah, I think even I would do that. My personal strategy is not to answer questions from geometry. I mean, there are enough questions otherwise which can be handled in 60 minutes of time, right? So I would, within quantitative aptitude, I would keep geometry aside. I'll answer the other questions first. Naresh, on the other hand, says he's little weak in arithmetic part, except that all is good. So it depends, right? I mean, everybody has got, their own strengths and weaknesses. So weakness here for Naresh is arithmetic part, which is my strength, which is strength for most of us. But yeah, never mind. Just do the remaining things well, right? I mean, whatever your strength lies in, that has to be focused more on, and you should score more there. Okay, Suresh says, I'm not confident getting 70 to 100 marks in the mock exams. How can I motivate myself? Well, motivate yourself by just surrounding yourself with positive things. I think, what can you do in the last 1 week? I mean, in terms of preparation, I don't think there can be a major change that you can undergo in the last few days of your examination, right? I mean, you should have prepared really well over the last couple of months, or since whenever you have started your preparation. But yeah, you have to feel confident, right? Sometimes you have to fake it. That's what I have learned, right? Even if you're not confident, just go walk into the examination center with full confidence, right? Like, you'll crack it. That confidence is important, right? That is the reason I say don't prepare till the last minute. Don't prepare till the last day of your examination, right? Enjoy. All work and no play makes Jack a dull boy, right? That is applicable here as well. So try to keep yourselves surrounded with positive things, think positive, right? And try to keep yourself mentally healthy during the examination. But looks like general awareness is the weakness for most of you, right? Yeah, it's unpredictable, like Santosh Kumar has mentioned. Praveen Piyush says, what's your sectional time division strategy in SSC CGL Tier 1? Well, I think, Praveen, we have discussed this already through various sessions. Out of 60 minutes that you have, let me quickly throw some light on this, right? I'm sure all of you are trying to get your own split of time across the 4 sections. So I think we have got 4 sections: quantitative aptitude, general intelligence and reasoning, English comprehension, and general awareness or general knowledge. And we have been given 60 minutes of time. So average is 15 minutes per section, but clearly sections like general intelligence and reasoning, or general awareness for that matter, do not need more than 10 minutes. Yeah, I mean, general intelligence and reasoning, like we have seen through our refresher sessions, is like very easy. You will take about 10 to 12 minutes at best to attempt all the 25 questions, right? To attempt all the 25 questions. So I think we can save some time in general intelligence and reasoning. We can save a lot of time in general awareness. General awareness, where we have 25 questions, should not take more than 7 minutes in my view. Yeah, I mean, even if each question, let's say, takes 20 seconds, what happens in general awareness? You either know the answer or you don't know the answer. Like, for example, there can be a question on I'm sure all of you must have learned about it yesterday. There can be a question on when is the Kargil Vijay Divas celebrated? 26th of July. Now you either know this or you don't know this, right? I mean, since it was being celebrated yesterday, I can recall it as one of the questions. So you know the answer or you don't know the answer, right? You cannot put in a formula there to arrive at any sort of answer. So how much time would a question from general awareness take? At best 20 seconds. You read the question, you mark the answer, or you just skip and go to the next one. So if it is 20 seconds per question and there are 25 questions, it is 500 seconds. 500 seconds is 8 minutes and 20 seconds. Let us say 9 minutes. So you need about 9 minutes for general studies. You need about 10 to 12 minutes for general intelligence and reasoning. So altogether 20 minutes of your time is enough to complete these two sections, right? Which have got 50 questions together. Remaining time is 40 minutes and you have two more sections, English comprehension and quantitative aptitude. Again, English comprehension doesn't need 15 minutes or 20 minutes, right? Again, about 12 minutes of time, right? It is, I would say it would take a little more time than general awareness and lesser time when compared to general intelligence and reasoning, because here again, there is no formula to be used. There are questions on synonyms and antonyms, there are questions on finding errors, there are questions on direct indirect speech, there are questions on active passive voice, there are questions on reading comprehension, which are all like, you know, read the question, maybe just go through the options and then mark the answer. You may spend a few seconds trying to eliminate some of the answer options, but otherwise it's not that time consuming. So English may take about, let's say, 10 minutes again. Yeah. So 8 minutes for general awareness, 12 minutes for general intelligence and reasoning, and about 10 minutes for English language. I'm trying to keep it a little too tight, I guess. You can do plus or minus 2 minutes here and there. So far we have spent 30 minutes in 3 sections. You have 30 minutes left for quantitative aptitude. Again, quantitative aptitude doesn't really need 30 minutes, about 20-22 minutes, let's say. 25 questions are there, 22 to 24 minutes. Or even if you spend 1 minute per question, you have 25 minutes. After that, you have 5 more minutes left, which you will have to, you know, use depending on the situation in the exam, right? Depending on what type of questions are asked, depending on, you know, what really happens there. I mean, it's like real-time scenario that nobody can predict. So, yeah, I think the point that I'm trying to make is, if you have to look at the way you spend time, the least amount of time is needed for general awareness, followed by English language, followed by general intelligence and reasoning, and maximum time is needed for quantitative aptitude. Yeah, there cannot be a hard and fast rule that you have to spend 12 minutes in general intelligence and reasoning. It again depends on your own strength, your own weaknesses, right? Depends also on the type of questions asked that day in the exam, right? That sort of the examination. So I don't want to fix it or freeze it that, you know, you have to spend so and so time in so and so section. Ideally, this is what will happen. Based on your strength and weakness, try to do plus or minus here and there, but not too much of deviation again is advisable, right? Plus or minus 2 minutes per section, I would say. Yeah, so try to follow it largely based on this, and I think give your best. Your single objective during that exam, let me tell you, should be to attempt all the 100 questions. Your target is to attempt all the 100 questions in 60 minutes of time. Which sequence you follow, how much time you spend per question doesn't really matter. Attempt all the 100 questions. Again, let me repeat. When I say attempt, I don't mean to say that you have to answer all the 100 questions. You may answer only 60 out of 100. That's okay. You may answer only 80 out of 100 questions. Absolutely fine. But make sure that you don't step out of the examination hall without reading all the 100 questions. Right? For me, attempting a question would mean going through that question. Whether you solve or not doesn't really matter. I mean, not that it doesn't matter, it definitely matters, but you know what is more important is to go through all the questions, play all the 50 overs and come back. That's the idea. I think on that note, let's get started. As you all know, today's session is on geometry. We have already had one session on geometry in the past where we have discussed a few questions from triangles, circles, quadrilaterals, etc. We'll take a few more questions today and kind of touch various concepts and theorems discussed through the videos, right? Videos are already there. I'm sure all of you have gone through those videos. This is just to revise and refresh those basics. So I'll share the screen, present the questions to you one after the other, give you some time to try it out as usual, and then discuss the solution. All right, so without wasting any time, let's go to the first question, which is on your screens now. So here's the first one. Try and solve this. See what it says. O is a point outside a circle and is 15 centimeters away from its center. A secant drawn from the point O intersect the circle at I1 and I2 in such a way that OI1 equals to 8 centimeter and 4 times of I1 I2 equals to 5 times of I1O. The radius of the circle is 8 centimeters, 9 centimeters, 10 centimeters or 7 centimeters. Since this topic is geometry, I would give you at least a minute to try this out, and your clock starts now. Let us see how many of you get the right answer. Nayan has marked the answer as 10, which is option 3. I'll wait for more responses before we take this up. Got it? Okay, Nayan and Neeraj, only 2 of you have got the answer so far, and that 2 different answers. Nayan has got 10, while Neeraj says it should be 8, both of which are there in the options. Let's wait for a few more responses. Murli Krishna has got 7, which also is there in the options. So 3 of the 4 options have already been covered, right? Let's see if you have any other answer there. And those who have not been able to solve it, those who are stuck, please do mention that to the chat so that I know what's happening at your end, right? If you need more time, mention that as well, right? That you are in the middle of the solution and you may need a few more seconds. Struck? Okay, so we have got a lot of students here who are struck and you are not able to arrive at the answer, which makes me a little happy, because whatever we are going to discuss now will be useful to many of you. So I think the first few responses were 8, 10, 7, all of which are there in the options. Then we have Milan, Nikunj Agarwal, Bhanu Priya, Ajay Kumar, Arvind, who are struck, and so are Avinash and Praveen. And then there are others who have got 8, right? Priyanka, Manas, Neeraj, these guys have got 8. Durga Prasad has got 7, and Parik Goel has skipped. So I think not many of you have got the answer. Looks like most of you are struck or you have skipped it. And those who have got have marked answers like 8 or 10 or 7. I think 8 is the most common response after going through all the responses here. So let's discuss this now. Shall we discuss? You need more time? I think time is up. Let's discuss this immediately. Yeah? Yeah, I think Genome, Pankaj, Parik, all these guys have skipped it. See, while I appreciate that you've done the right thing by skipping the question, right? See, when you do not know how to solve the question, or when you have no clue about how to arrive at the answer, you are better off skipping it, right? Don't waste your time there. Right? There are other questions to be attempted. That's what I'm telling you. It's an attempt. You have attempted the question. You have decided that you don't want to solve it. You have skipped it. It was a cautious decision. So I appreciate your idea of skipping the question. What is not very satisfactory here is the amount of time that you have taken to skip it. Ideally, you should have skipped it in like first 10 seconds, first 15 seconds, right? Don't wait for me to tell that you have to skip it, right? Just skip it and just tell me that you don't want to solve it, because if you spend 1 minute and then decide that you should skip it, it's a waste of your time. Yeah. So let's discuss the solution now. Here we go. So the question says O is a point outside a circle and is 15 centimeter away from its center. A secant drawn from this point O intersects the circle at I1 and I2 in such a way that OI1 equals to 8 centimeters and 4 times of I1 I2 equals to 5 times of I1 O. The radius of the circle is. Options given are 8 centimeters, 9 centimeters, 10 centimeters or 7 centimeters. Right? So let's draw the diagram and understand what's happening here. O is a point outside the circle and is 15 centimeter away from the center. So let's consider a circle. Okay, it doesn't look like a circle. Let me redraw it. Yeah. So let's say this is the circle. The center here is this. Now O is a point outside the circle and is 15 centimeter away from its center. So let's say O is the point here. This is the point O. And this is the center of the circle. Let's say C is the center of the circle. So what's the distance between C and O? 15 centimeters. Right? The distance between C and O is 15 centimeters. Now a secant is drawn from the point O which intersects the circle at I1 and I2. So from the point O you draw a secant. What is a secant? A secant is a line drawn from an external point which intersects the circles at 2 points. Yeah. So let's say this is the secant. So you can see that from the point O, this is the point O, right? From this point, when you draw a line, it intersects the circle at this point, which is, let's say, I1, and then this point, which is I2. So it intersects the circle at 2 points, I1 and I2. I1 and I2. In such a way that OI1 is 8 centimeter. OI1. You getting it? Look at this. This is the point O, right? So OI1 is 8 centimeter, right? This is 8 centimeter. This is 8. OI1 is 8 centimeter and 4 times of I1 I2 equals to 5 times of I1 O. 4 times of I1 I2 equals to 5 times of I1 O. Then he's asking us to find out the radius of the circle, right? What is the radius of the circle? See, let me just draw a straight line from the point O in a fashion where it passes through the circle, passes through the center of the circle. Yeah. I mean, I'm trying to draw a neat diagram, so it is taking so much of time. You know, when you're solving it yourself, you don't have to worry about neatness there. So this is the center of the circle. So from the point O, the secant is this, OI1, I2, and this is another line, right, which is passing through the center of the circle, which means this segment of the line is the diameter. This segment of the line is the diameter. Let's say the diameter is AB. The diameter is AB, yeah, and center of the circle is C. So basically AC is equal to R and CB is also equal to R. Radius, right, from the center to any point of the circle is the radius. So AC is R or CA is R and CB is also R. Now consider this equation given to us. 4I1 I2 equals to 5I1 O. 4I1 I2 equals to 5 times of I1 O. What is I1 I2? I1 I2 has to be calculated. But what is I1 O? It is equal to 8, right? So from this we can say I1 into I2 equals to 5 by 4 into I1 O. What is I1 O? I1 O is 8. How much is this? It goes 2 times, gives us 10. So basically I1 I2, this segment is equal to I1 I2. This segment comes out to be 10, right? So OI1 is 8, I1 I2 is 10. I1 I2 is 10. That's what we've calculated. Now there's one very important theorem that we have discussed in circles. If you recall the videos that we have covered in the topic of circles, right, under geometry, one important application that you need to remember is from an external point, these are like 2 secants, right? I mean, OI1 I2 is 1 secant, OBA is the other secant, right? So the point here is OI1 into OI2 is equal to OB into OA. You understand? From the point O, OI1 and OI2. From the point O, OB and OA. Both are like points where the lines intersect the circle, right? So OI1 times of OI2 should be equal to OB times of OA. This is a very important theorem that you need to remember, right? That's it. Now try and substitute the values here. What is OI1? OI1 is equal to 8. What is OI2? See, OI2 is 8 plus 10 total. 10 plus 8, which is 18, right? Total is 18. So OI1 is 8, I1 I2 is 10. So that makes OI2 equals to 10 plus 8, 18. So this is 18, which is equal to OB. OB, what is OB? See, understand, we know that OC is 15. This total length is 15. From 15, if I subtract the radius r, I'll get OB. So OB can be taken as 15 minus r. Into what is OA? O times A. Sorry, OA. What is OA? OC is 15 and CA is r. So OA becomes 15 plus r. 15 plus r. That's it. One equation and only one variable. R is the only variable. Can you solve for it? And that is the requirement, right? He's asking us to find out the radius of the circle. So 8 times of 18 is 144, which is equal to, this is a plus b into a minus b, a squared minus b squared. So 15 squared, 225 minus r squared. So from this, r squared comes out to be 225 minus 144, which is 81. Yeah. So if r squared is 81, r will be 9. So 9 centimeter is the answer. Option 2. 9 centimeter is the answer. All right. I think a very interesting question. The most important part here is this. You got to remember this. OI1 into OI2 equals to OB into OA. Yeah. OI1 into OI2 equals to OB into OA. Rest is just playing with those equations, finding out the different line segments and substituting the values or the equations there to get the required answer. Yeah. Option 2. So you know what is interesting? Not many of you were able to solve it, right? Most of you skipped or got stuck. Few of you could solve it. And those who all solved got the answer as either 8 or 7 or 10. I mean, until I started solving it, nobody had marked the answer as 9. Now I see a couple of responses here, like 9, like Satish has mentioned 9. I think Sumit Kumar Pandit has got 9. Nikunj Agarwal has changed it to 9. Amit Kumar has got 9. Yes, Srinivas has got 9. But before I had started, I think the different responses that we got were 8, 7 or 10. Yeah. So I think everybody failed. You failed because you couldn't solve it, you skipped it, you got stuck. And those who solved it also got failed because they got wrong answer. So I think the best in this situation is to skip and go to the next one. When you have no idea about how to approach. See, when you read the question, you get some sense of it, right? You know that you can try it out, or you would realize that, okay, this can be complex. I don't think I can crack it. Just skip and go to the next one. Mark it for review. Come back later, right? Ideally, what I would do is avoid all the geometry based questions, because by the time you draw the figure, 30 seconds, 40 seconds are gone. Yeah. Reading the question and drawing the figure itself would take about 30-40 seconds. And after that, you have to do something to get the answer. So my strategy is to avoid questions from geometry. Solve the other questions first, then cover the remaining sections. And if time permits, come back. That's what I would do, because if you ask me, geometry is not my strength when compared to the other topics, right? So yeah, preparation alone is not going to help. You have to have a right strategy with you. Should we go for the next one? I'm sure all of you have followed this. Yeah. Any confusions anywhere? Satish and Ram Babu have also got 9. Is this clear to all of you? Can we go to the next one now? Next question. Should we move to the next one? Quick. We have time till 8 p.m. So let's try and cover as many questions as possible. Should I go for the next one? Yeah, I think Yashveer, Amit Kumar, Mamta, Satish, Nikunj Agarwal, these guys have acknowledged that they've followed it, and we can go to the next one now. So let me share the next question with you all. And here's the next one. In a quadrilateral ABCD, angle CAB equals to angle DAC. Yeah, angle BCA equals to angle ACD. Then find the area of the quadrilateral ABCD if the area of ADC equals 24 centimeters square. You have 1 minute here again, and the time starts now. Got the answer? Yeah, so many of you have solved it this time, and the responses that I see are 48, 32, 48, 48. I think most of you got 48. Only one person here has marked the answer as 32, and that is Neeraj. And then Naresh has also got 32. Yeah, let's take it up now. I think 48 versus 32 is what we are trying to finalize here. So the question says, in a quadrilateral ABCD, angle CAB equals angle DAC, angle BCA equals angle ACD. Find the area of the quadrilateral ABCD if the area of triangle ADC is 24 centimeters square. So again, it's about getting the diagram right? He's talking about a quadrilateral ABCD. Let's say this is a quadrilateral. I mean, some quadrilateral there. You can take any shape, right? A, B, C, D. Right? Now you don't really know if the quadrilateral is in this shape, right? It could be a perfect square, or it could be a rectangle, or it could be a parallelogram, or it could be a random shape there. But then ABCD is a quadrilateral. He says angle CAB equals angle DAC. Angle CAB equals angle DAC. So basically, if I draw a line joining these two ends, right, the diagonal there, right, it says angle CAB. What is angle CAB? This angle, angle CAB, equals angle DAC. Angle DAC. So basically, these two angles are equal. These two angles are equal. And then he says angle BCA equals angle ACD. Angle BCA, BCA. BCA is this angle, equals angle ACD, ACD, BCA equals ACD, right? So these two are also equal. These two angles are also equal. Find the area of the quadrilateral ABCD. So we got to find out the area of this quadrilateral ABCD if the area of triangle ADC is 24 centimeters square. So there are two triangles that are formed here, if you see, right? One triangle is ABC, the other triangle is ADC. So the area of the triangle ADC is 24. The area of this triangle is 24. He's asking us to get the area of the quadrilateral ABCD. Now, simple observation here is that the two triangles are similar. Yes or no? The triangles here are similar. They've got the angle side angle symmetry, right? I mean, similarity. These two angles are equal. These two angles are also equal. Yes or no? Triangle ABC is similar to triangle ADC. Why is it so? See, angle A here is equal to the angle A here. The two angles are equal, right? Then angle C here in triangle ABC is equal to the angle C in triangle ACD, right? These two angles are also equal. And then AC is the same side, right? Both of them have got the same side, AC. AC side is also equal. So one side and two angles are equal, which means the triangles are similar, right? Triangles are similar. I mean, symmetric basically. So if this is 24, this also has to be 24. Yes or no? Both are equal triangles basically. Two of the angles are equal, right? I mean, if two angles are equal, obviously the third angle also will be equal. So this shape that we have done actually is incorrect. It has to be like a proper square, right? But anyway, I can then conclude that these two angles are also equal, because sum of the angles in a triangle is 180. So two angles are equal. The third angle also has to be equal. There's no choice. So both the triangles are equal. Yeah. So if this is 24, this also has to be 24. That means the area of the quadrilateral will be what? 24 plus 24, 48. Option 3 is the answer. Yeah. So ABCD is 24 into 2, 48 centimeters square. 48 centimeters square, option 3. I'm sure simple one, right? There's no confusion there. Congruency, of course. Side angle side or angle side angle. Yeah. It will be like a rectangle basically. The quadrilateral here has to be in the shape of a rectangle. Only then the two are congruent. So if the lower half is 24, the upper half also would be 24, which makes the area of the quadrilateral 48. I think simple one. Let's jump to the next question now. Yeah. Here's the next question. Now this one says in a trapezium ABCD, angle BAD is 30 degrees, angle CDA is 45 degrees. BC equals 12 centimeter and AB equals 24 centimeter. Find the area of the trapezium. And typical options here, right? 72 root 3 centimeter squared, 36 root 3 centimeter squared, 72 times of 3 plus root 3 centimeter squared, 36 times of 3 plus root 3 centimeter squared. Yeah. So I'll give you at least a minute to try this. Let's see how many of you get the right answer. Skip. Somebody says this looks like a tier 2 question. Well, yeah, a little time consuming, but can be asked in tier 1 as well. Most of you have skipped it, huh? So if I look at the responses, Nayan has skipped it. Manas Ranjan has got option 3, which is 72 times of 3 plus root 3. Neeraj has skipped. Milan has got option 4, 36 times of 3 plus root 3. Then Priyanka, Bhanu Priya, Nikunj Agarwal, Sai Krishna, all these guys have skipped. Yeah. Satish has skipped. So has Neeraj Jha and Ram Babu. Then Amit Kumar says, if we take ABCD as a chord. Okay, I don't know what he's referring to. Mamta has skipped. Amit Kumar says BAD and CDA angles. How is this possible? BAD and CDA. Mahata has also skipped. Should we take it up now? Anyone who's in the middle of the solution and wants a few more seconds? I think 10 more seconds and we'll close it after that. So I think it's about getting the figure right. If you have drawn the figure properly, then you can solve it without any difficulty. Yeah. So let's start solving it now. I think we have spent enough time. Let's discuss the solution now. Option 3 is what Manas has got. So here we go. The question says, in a trapezium ABCD, angle BAD equals to 30 degrees, angle CDA equals 45 degrees. The side BC is 12 centimeter and AB equals 24 centimeter. Find the area of the trapezium. So basically he's talking about a trapezium and has asked us to find out the area of the trapezium where one angle is 30 degrees, the other angle is 45 degrees. One of the sides is 12 and the other side is 24. So let's make this trapezium here. So let's say it looks like this. ABCD is a trapezium, right? So A, B, C, D. Yeah, ABCD. He says angle BAD is 30. BAD, angle BAD. So this angle here is 30 degrees. Yeah. Angle CDA. This angle is 45 degrees. Yeah. Both these acute angles you can see, right? 30 degrees and 45 degrees. BC is 12. This length is 12. BC is 12 and AB is 24. AB, this slant length is 24. Find the area of the trapezium, right? How do you get the area of the trapezium? Now you know that area of the trapezium here will be half of AD plus BC, or basically the average of the two parallel sides multiplied with the height. Let's say the height of the trapezium is h, right? Multiplied by height. This is how you get the area of the trapezium. This is the formula. So there are two ways to find out the area. I mean, either go by the formula when you know all the variables here, right? The length of the two parallel sides is known to us, and if the height is known to us, simply substitute the values here. Average of the two parallel sides multiplied by height will give you the area of the trapezium. Or the other way to solve the question is to break this trapezium into three parts, into three different geometric figures, I would say, right? Like for example, if I drop a perpendicular from point B onto the side AD, similarly drop a perpendicular from point C onto the side AD. Let's say these are points M and N. So what happens? ABM is like a triangle, CDN is also a triangle, and BCNM is a rectangle. So find out the area of the triangles, find out the area of the rectangle, and then add all three to get the area of the trapezium, right? In that case, area of the trapezium will be area of this triangle plus area of the rectangle plus area of this triangle. Yeah. So let's solve this now. I think the whole idea is to find out the side BM. I mean, find out BM or CN. BM CN will be equal to H. Remember, in that case, BM here will be equal to CN will be equal to H. So if you're able to find out the length BM, you get the height of the trapezium. Yeah. So let's consider the triangle ABM, right? The triangle ABM. What do you see here? In triangle ABM, apply trigonometric ratios, right? So can I say sine 30 is equal to opposite side by hypotenuse? This is like a right angle triangle, right? It's a perpendicular. This is 90 degrees. This angle is 90 degrees. Right? Similarly, this angle here is 90 degrees. So both angle M and angle N are 90 degrees. So in a right angle triangle, you can apply the trigonometric ratio. Like I can say sine 30 is opposite by hypotenuse, right? So sine 30. So what is sine 30 by the way? 1 by 2. Sine 30 half is equal to opposite side, which is BM. Opposite side BM by the hypotenuse. What is hypotenuse? AB, which is 24. So can I say BM equals to 24? Yes, BM equals to 24, which should be equal to the height of the triangle, and that should be equal to the side CN as well. You're getting it? We have found that BM is 24. Sorry, 24 by 2, 12. Yeah, BM equals to 24 by 2, 12. So this is 12. BM equals to 12. And so is CN. Both are parallel, right? Both are parallel because these are perpendiculars dropped from points B and point C onto the same side AB, which is the height of the trapezium. So we've got 12. So height is known to us, by the way. Yeah. We also know that BC is 12. BC equals to 12. All we need to find out is AD. I mean, if I have to use the formula, what is the question mark here is AD. If I can get AD, then we'll be able to use the formula and get the answer. Now, what is AD? AD is AM plus MN plus ND. This length AD is equal to AM plus MN plus ND. ND has to be calculated. MN will be 12. See, if BC is 12, MN is also going to be 12. MN will be equal to BC, which is equal to 12. Because if you observe, BC and M makes a rectangle, right? Opposite sides are equal. So if this is 12, this also would be 12. So MN is 12. So MN is known to us. All we have to find out now is AM and ND. AM and ND, right? By the way, in the same triangle ABM, how can you find out AM? Apply the cos theta, right? Cos theta is adjacent by hypotenuse, right? So I can say cos 30, what is cos 30? Root 3 by 2 equals to adjacent side. What is adjacent side? AM by the hypotenuse, which is 24. So from this, AM comes out to be what? AM will be 24 root 3 by 2 or 12 root 3. AM equals to 12 root 3. So AM also has been calculated. So we know AM, we know MN, and what we need to find out is ND now. How do you get ND? So now consider the triangle CDN, right? CDN. I can say tan 45 degrees. What is tan 45? Tan 45 is 1, right? Tan 45 is equal to what? Opposite by adjacent. Opposite by adjacent. This is the hypotenuse, right? Opposite by adjacent. So Cn by Nd. Cn by Nd. Cn, which is 12. Remember, height is 12, Bm, Cn all are 12, right? Cn equals to 12. We have calculated. So Cn, opposite side by adjacent side, Nd. So from this, we come to a conclusion that Nd is equal to 12. So Am has come out to be 12 root 3. This is 12 and Nd is also 12. Yeah. So what is the total length AD now? We can say AD equals to 12 root 3 plus 12 plus 12. That's like 24 plus 12 root 3. 24 plus 12 root 3. Done. So the only question mark we had was AD, which also has been calculated, 24 plus 12 root 3. Now substitute in the formula. So therefore the area here will be half of AD plus BC. AD is 24 plus 12 root 3. 24 plus 12 root 3 plus what is BC? Did we calculate BC? BC is 12, right? BC is 12. Multiplied by the height. What is the height? Height also is 12. Yeah. So I think this goes 6 times. And now you simplify. So 24 plus 12, 36. Yeah. Or I guess we can take 12 common, right? What is there inside the brackets? We can take 12 common. So if you take 12 common, this is like 36 plus 12 root 3. If you take 12 common, it becomes 3 plus root 3. 3 plus root 3 inside the brackets, and outside we have 12 into 6, 72. So I think the answer will be this, option 3. It comes out to be 72 times of 3 plus root 3 centimeters squared. 72 times of 3 plus root 3, option 3 would be the answer. You're getting it? So I think just remember that the area of a trapezium is the average of the parallel sides multiplied by the height. Yeah. So based on the angles and the sides given there, you got to find out the height, right? And then the other requirements that we have and substitute the values. And like I said, the other way to solve it is to find out the 3 areas. Area of the triangle ABM, area of the triangle CDN, area of the rectangle BCNM. And then add all 3 to get the overall area of the trapezium. It is time consuming, but there is no other way out. You have to solve it this way. You have to use trigonometric ratios to get the heights and all that. See, different angles, different sides can be given, but the approach remains the same, right? Find out the missing parameters and then substitute the values in the area formula to get the required answer. There's no shortcut in my view. Yeah. So final answer is 72 times of 3 plus root 3 centimeters squared, which is option 3. Let me quickly see if you have followed this. Time taking. Yeah, Praveen says it's time taking. Nikunj Agarwal has got option 3, by the way. Santosh says, is this a previous year question? Could be. I'm not sure. It could be one of the previous year's question. Yeah. Yeah, I think drawing the right figure was the clue. Neeraj has mentioned that. I've told you, right? I think the most important part in solving questions from geometry is to get the figure right. You have to be very careful. I mean, like, for example, the parallel sides that you consider. If you consider AB and CD to be the parallel sides here, you will not be able to complete it. You got to understand that AD and BC are parallel because angles CDA and angle BAD are both acute, right? 45 and 30 respectively. So it means that AD is parallel to BC and not the other way. Okay. It will not be time taking if we know quick calculations, is what Manas says. Yeah, I think calculation is one thing. The other thing is figure. Geometry is not just calculation. You have to understand the figure properly. You have to be able to visualize it properly and then put it on paper, find out the missing values. And yes, then calculation is definitely an important piece of component there, right? Yeah, so should we go for the next one? I'm sure you've followed this, right? So practice a couple of more questions based on the same format. Get the concept right and then you should be able to solve. Ram Babu says how to mark ABCD points in the right way. That's what I told you, right? Ram Babu, ABCD, marking those 4 vertices itself is the biggest challenge. You look at the way we have taken ABCD, right? A, then B, C and D. You don't take ABCD like this because in that case, the angles that are given there, CDA and BAD, both are acute. But you will find that one becomes obtuse. Obtuse angle cannot be less than 90 degrees, right? see, it's obvious that initially we take A, B, C, D, but after marking the angles, you figure out that it's not A, B, C, D this way, but A, B, C, D in the clockwise direction. It's not in the anti-clockwise direction, but in the clockwise direction. Yeah. Neeraj says, I took the intelligent step to skip it earlier. Yeah, I think if you have skipped it in the first few seconds, you have followed the right solution. Should we jump to the next one now? Yeah. Let's take the next question. On your screens now. It says the tangents at 2 points A and B on a circle with center O intersect at P. Intersect at point P. If in quadrilateral PAOB, angle AOB is to angle APB is 5:1, then the measure of angle APB is, what's the measure of angle APB? Interesting one again. See if you are able to crack this. Got it? 30 degrees. Yes. All of you have got 30? Good. So glad to see that you're not getting stuck in simple ones, right? Sushant Singh, Amit Kumar, Nayan, Milan, Bhavani, Nikunj, Parekh, Monica, Sonu Kumar, Sonika Yadav. All you guys have got 30, right? Pankaj has also got 30. Neeraj Jha has got 15 degrees, option 4. So there's some difference in opinion there. But then again, we have Murli Krishna, Neeraj, Suresh Rana. We've got 30. Oh, sorry, Neeraj has got 60, option 2. Vineet has got 30. So let's take this up. Yeah? Should we take it up? Yeah, Murli Krishna is right. The tangent makes an angle of 90 degrees with the line dropped from the center of the circle onto the point of contact. So that's the key. If you know that, if you realize that while solving this question, then you're done. Yeah. So here we go. The question says the tangents at 2 points A and B on the circle with center O intersect at P. If in quadrilateral PAOB, angle AOB is to angle APB equals to 5:1, then the measure of angle APB is. Yeah. So he says there are two tangents at points A and B on a circle with the center O, and these two tangents intersect at what point? At the point P. So let's draw the figure first, right? Let's say this is the circle. Let's say the 2 points are these, right? Point A and point B. So tangents at point A and point B intersect at a point P. So they intersect here, let's say, the point P. And O is the center of the circle, by the way, right? O is the center. Yeah. Tangents at the points A and B intersect with the center O intersect at P. So this is how the figure looks like. Now, if in this quadrilateral PAOB, the quadrilateral PAOB, so let's construct the quadrilateral. So basically from the center, you have to drop a line on the point of contact A and another line on the point of contact B. You know that from the center of the circle, when you drop a line on the point of contact of tangent with the circle, it makes an angle of 90 degrees, right? These angles made will be 90 degrees. OA and PA will be perpendicular. OB and PB will also be perpendicular. Always standard, right? You have to remember that. One of the basic concepts in the topic of circles, right? From the center of the circle, the line drawn to the point of contact, the point of tangency, always makes an angle of 90 degrees with the tangent. So these two are 90 degrees. Now he says that the quadrilateral PAOB, in this quadrilateral PAOB, this is a quadrilateral, angle AOB, this angle, let's say this angle is let's say X, right? Angle AOB and angle APB are in the ratio of 5:1. angle APB, angle APB, yeah, they are in the ratio of 5:1. Then what is the measure of APB? APB is equal to, what is the question? APB equals what? So basically he says angle AOB, or yeah, I think first of all we got to understand that the sum of all the angles in a quadrilateral is 360 degrees. Yeah, out of which 90 and 90 are gone here, 180 is gone. So what is remaining? 180. So I can actually conclude that angle AOB plus angle APB will be equal to 180 degrees, because 90 and 90, 180 is gone. Out of 360, 180 is gone in these two angles. So the sum of the other two angles has to be 180. But then these two are in what ratio? 5:1 ratio. Angle AOB, angle APB are in the ratio of 5:1, which means this is like 5x plus x equals to 180. So 6x is 180, which implies x is equals to 30 degrees. I think this is, I should not take it as x, I should take it as 5x, and then this is x. They're in the ratio of 5:1, right? So if this is x, this will be 5x. What is he asking us to find out? He's asking us to find out the angle APB. Angle APB is x, which is 30 degrees. Option 1 is the answer. Yeah. He can also ask you to find out the angle AOB. Angle AOB will be 5x. So 5x is 150 degrees. All right. So I think a sitter from circles, you should not be committing any mistake while answering such questions in the exam. Now my question is to those who have got 15 degrees or 60 degrees as the answer. Is the confusion cleared now? Are you clear with the solution? Nayan says sum of opposite angles in a quadrilateral is 180 degrees. No. Nayan, if you have used that as the idea, I would say you are lucky that you have got the right answer, because it is a coincidence that here the sum of opposite angles is 180 degrees. Remember, it is not a rule that sum of opposite angles in a quadrilateral is 180 degrees. This case, it actually so happens that the sum of opposite angles comes out to be 180 degrees, but that's not a rule. So all those who have used that as the idea to solve the question would have got the right answer, 30 degrees. But then I would say you are wrong. Your answer is right, but you are wrong. And I think now this makes me curious. How many of you have used that as the logic? How many of you have used the logic that opposite angles make 180 degrees? Like Murli Krishna was right. Murli Krishna said the tangent makes an angle of 90 degrees. So the line from the center of the circle to the point of tangency will make an angle of 90 degrees with the tangent. That's the right logic. But stating that opposite angles make 180 degrees is not the right logic. So Nayan, you are very lucky that you've got the right answer, 30 degrees. Neeraj says I made the wrong diagram. Yeah, diagram is the key. It's possible only in a cyclic quadrilateral, right? Milan is right. Sum of opposite angles is 180 degrees only when the quadrilateral is cyclic. Only when the quadrilateral is cyclic, then we find that sum of opposite angles is 180 degrees. You're getting me? What is a cyclic quadrilateral? If you can draw a circle using, in a way that, or if all the four vertices of the quadrilateral lie on the same circle, then it's called a cyclic quadrilateral. If all the four vertices of the quadrilateral lie on the same circle, then it is considered to be a cyclic quadrilateral, which would happen in this case. I mean, the fact that opposite angles are 180 degrees shows that it is a cyclic quadrilateral. So I can draw a circumcircle to this quadrilateral. But that's not possible always, right? That's not possible in every quadrilateral. Okay, I think glad that all of you have got 30. I'm still not sure how many of you use the right logic, right? Remember, sum of opposite angles in a quadrilateral need not be 180. Sum of opposite angles in a quadrilateral is 180 if and only if it's a cyclic quadrilateral. On that note, let me move to the next question. Next question from geometry. Here we go. Now this is on triangles. It says ABC is a triangle, right angled at B, and M and N are midpoints of AB and BC respectively. Then what is 4 times of AN square plus CM square equal to? This is going to be an interesting one. ABC is a triangle, right angled at B, yeah, and M and N are midpoints of AB and BC respectively. So what is 4 times AN square plus CM square equal to? Sushant Singh has already marked the answer. He said it should be 5 AC square. Interesting. Waiting for others. Sai Krishna has got 4 AC square, option 2. Chandra Neeraj has also got option 2, 4 AC square. I'll wait for more responses. I want all of you to give it a try. Got it? Okay, Nikunj Agarwal has marked the answer as option 4, which is 6 AC squared. Murli Krishna has got option 2, option 3, 5 AC squared. Then we have Venkat, who has got 5 AC squared. Neeraj has got 4 AC squared. Manas Ranjan has mentioned that it's buffering. Well, I don't see any challenge at R in Manas. I think stream is going absolutely fine. You got to check your bandwidth, right? Internet bandwidth at your end. Amit Kumar has skipped it, stating that it is lengthy. Parik Goel has also skipped. And others have got option 2, option 3, option 4. I think all sorts of answers have been given, except option 1. I think all the other options have been marked. 4 AC squared, 5 AC squared, 6 AC squared. Should we take it up now? Quick. I'm asking this again if I can start the solution, just because I don't want to disappoint those who are about to close it, right? They would get distracted. So I am ready to give you a few more seconds if you're about to finish it. Because getting the answer yourself is more important, right? Knowing the answer is not important. Knowing the solution is not important. Getting it yourself will give you enough confidence. Amit Kumar says D is the answer, 6 AC squared. Ram Babu has skipped it after a long time. After spending so much of time, you cannot skip it. Anyways, should we take this up now? Yashvir has also got option 4, 6 AC squared. Proceed. Chalo, I got the instruction to proceed. So let me take this up now. So the question here says, if ABC is a triangle right angled at B and M and N are midpoints of AB and BC respectively, then what is 4 times AN square plus CM square equal to? Right? So it looks like a simple question. Let's draw the figure properly and try this. So ABC is a triangle right angled at B, right? So we have to consider a triangle, a right angle triangle, and the right angle should be at point B. So let's say this is the right angle triangle. So B is right angle, right? 90 degrees. 90 degrees. So ABC is the triangle. ABC is the triangle. M and N are midpoints of AB and BC respectively. M is the midpoint of AB, N is the midpoint of BC. So midpoint of AB is M, and midpoint of BC is N. These are the midpoints of AB and BC respectively. Then what is 4 times AN squared plus CM squared? Yeah, so AN, let's connect this, AN, yeah, and CM. Yeah, and this is the right angle triangle. Remember, angle B is 90 degrees. So 4 times of AN square plus CM square. So basically we are looking for what is AN and CM, right? We have to evaluate AN and CM here. See, consider the triangle ABN. Consider the triangle ABN. ABN. It's a right angle triangle. Remember, this also is a right angle triangle because B is involved, right? Right angled at B. If it is a right angle triangle, Pythagoras theorem holds true. So can I say AN squared hypotenuse, right, equals to AB squared plus BN squared. AN squared hypotenuse squared equals to the sum of the squares of the perpendicular side. So AB squared plus BN squared. Yeah, but then BN will be half of BC. Why is BN half of BC? See, BN is equal to half of BC because N is the midpoint of BC, right? N is the midpoint of BC. So BN is half of BC. So let's take BC there. So AB squared plus BN is half of BC. So BN square will be BC squared by 4. BC squared by 4, right? BC by 2 whole squared. So BC squared by 4. That's 1 point, right? We have got AN squared here, right? Now try and find out CM. Now to consider CM, you have to consider the triangle MBC, right? Consider triangle MBC. Again, right angled at B. Right angled at B. What do you see here in the triangle MBC? In the triangle MBC, we find that this again is a right angle triangle. So Pythagoras theorem holds true. So hypotenuse square, which means CM squared, equals to sum of the squares of the perpendicular sides. So BM squared or MB squared plus BC squared. MB squared plus BC squared. Yeah, BC squared. But then again, we know that MB is half of AB. MB equals half of AB because M is the midpoint of AB, right? So it will divide the side into 2 equal halves. So MB is equal to half of AB. So MB is half of AB. MB square will be AB square by 4. So it's like AB squared by 4, right? AB by 2 whole square. So AB squared by 4 plus BC squared plus BC squared, which is equation 2. And here we've got CM square. So that's what we're looking for, right? AN square and CM square. So AN square and CM square. Now substitute. So basically, instead of substituting, let's add 1 and 2. 1 plus 2. What do we get? We get AN squared plus CM squared equals to AB square plus BC square by 4. AB squared plus BC squared by 4 plus AB squared by 4 plus BC square. Yeah, so see, connect these two. So what happens? AB square plus AB square by 4. So this is like 5 AB square by 4. Similarly, BC square by 4 plus BC square. So 5 BC square by 4. Yeah. So this is like, if I take 5 by 4 common, I'll get AB square plus BC square. AB square plus BC square. AB square plus BC square. But again, if you see AB square plus BC square should be AC squared. Since this is a right angle triangle, since the triangle is right angle, can I say AB squared plus BC squared, the sum of the squares of the perpendicular sides, equals to AC squared? Yes. The same identity has been used in the other 2 right angle triangles as well, right? So AB squared plus BC squared can be replaced with AC squared. AC squared. We are done. So AN square plus CM square equals to 5 by 4 AC square. Take this 4 on the other side. So what do we get? 4 times of AN squared plus CM squared equals 5 times of AC squared. 5 times of AC squared, which is option 3. And that's the answer. And having solved this now, see, this is the traditional method and this is the method. This is the way you solve it. But then one shortcut is you learn this answer by heart. in a right angle triangle, when he's talked about the midpoints of the other two sides, right? Midpoints of the two perpendicular sides, and asked you to find out 4 times of an squared plus cm squared. You understand, right? What is an? An is the line joining the vertex to the opposite side's midpoint, and cm is the line joining the vertex C to the opposite side's midpoint. So 4 times of an square plus cm square will be 5 times of ac square, 5 times the original hypotenuse square. If you can remember this, if you can learn this by heart, this question can be answered in 0 seconds. You getting it? So this is like a standard question. It's a standard question. It cannot be changed. There can be no change in this question. It has to come only in this fashion. Of course, the variables used may change. Instead of triangle ABC, he can talk about a triangle PQR. He can talk about a triangle MNO or LMN. But you have to remember the whole idea that when you are considering the two midpoints of the perpendicular sides in a right angle triangle, and then when he says 4 times of, vertex joining the midpoint square plus other vertex joining the midpoint square, it should be equal to 5 times the original hypotenuse square. Original hypotenuse here is AC. So 5 AC square, 5 AC square. Standard question, and hence the standard answer. It has to be 5 times of the hypotenuse square. Remember, 4 times of this should be 5 times of this. Suppose in the exam, if they simply ask what is an square plus cm square, then your answer should be 5 by 4 AC square. You getting it? So you have to remember it perfectly that, okay, 4 times of an square plus cm square is equal to 5 AC square. Yeah. So if you can learn it by heart, then it's like a sitter, right? Without putting pen on paper, you can mark the answer in 0 seconds. Otherwise, also solving it would take some time. I mean, you have to draw the figure and do these steps, right? You can cut down a few steps, of course, but it'll take about 1 minute or a little more than 1 minute maybe. Yeah. But option 3 is the answer. Amit Kumar says I skipped in 2 seconds. Yeah. So you either directly mark the answer in 1 second if you can learn this by heart. Standard question, like I said, or skip it in 2 seconds, or do this in 1 minute. Yeah. Sushant Singh, look at Sushant Singh. He says I learned it by heart. That's the reason I answered in 10 seconds. Typing time 10 seconds. Yeah. I actually sense that, Sushant, the kind of reaction you gave, right? The moment the question was presented, within no time I got Sushant's response. He said 5 AC square, and in fact he was the only guy who said 5 AC square. All others after that, most of them said 4 AC square, 6 AC square, etc. So I got a feeling that maybe you know it already. You've solved it already. You'll have learned it by heart. So that's the fact. See, Sushant would get 1 mark for this question, or 2 marks. In fact, geometry or the tier 1 exam has got a weightage of 2 marks per question, right? So Sushant would score 2 marks in like 2 seconds. Yeah. Others would take 1 to 1.5 minutes, and smart students will skip and go to the next one. But the winner is Sushant. 2 seconds, 2 marks. Yeah. Should we go for the next one? Amit Kumar has also mentioned that, Sushant, I knew this, that you have learned it by heart. Yeah, all others have changed their answers now. My mistake, it should be option 3. But you don't get this luxury of changing the answer in the exam, right? Unless you figure it out yourself. Okay, so can I go for the next one? Quick, we are at like 7:20 already. Only 40 minutes left for the session. Let's solve a few more questions. Shall I present the next one now? Guys, quick. 4 times of an square plus cm squared equals to 5 times of AC squared. Clear to all of you? Yes, no, struck? What happened? Looks like the chat is not working. Yeah, next one. I've got some confirmations there. So let me present the next question to you all, and on your screens now. It says ABC is a right angle triangle with right angle at B. Okay, similar to the previous statement only, right? Previous question statement. If the semicircle on AB with AB as diameter encloses an area of 81 centimeter square, and the semicircle on BC with BC as diameter encloses an area of 36 centimeter square, then the area of the semicircle on AC with AC as a diameter will be. Wow. This again, if you know the standard method, I mean, if you have solved such questions in the past, you will answer this in like 3 seconds, not more than that. Others would take about 1.5 to 2 minutes. And smart students will skip and go to the next one. Yeah. So I'll anyway give you some time. I want all of you to try it out yourself and see if you are able to crack it. Your time starts now. Got it? 121. Neeraj Jha says it should be 81 plus 36, which is not 121, it should be 117. Monica has got 121. Okay, Sai Krishna has got 121. Durga Prasad has got 121. All right. I know all those who have marked 121 are using one logic. I mean, I'm assuming that your logic is it has to be a perfect square. 81 is a perfect square, 36 is a perfect square. So maybe this also should be a perfect square. And the only perfect square that we have in the options is 121, which is 11 squared. If that's the logic you have used, you're taking too much of risk in your exam. I mean, good, odd one out. That's like classifying, right? Classification. Find out the odd one. The odd one here is 121 because that's the only perfect square. But be careful, guys. These logics don't work always. Manas has skipped it. I think Vineet and Neeraj have got 117. All others have marked 121, which can be the answer. I'm not saying that the logic is incorrect, but all I'm saying is it may not work always. Amit Kumar says it should be more than 117 and the only option near 117 is 121. So maybe that's the logic he has used. I don't understand the reason behind that reason that you have given. Nikunj is stuck. Milan has got 117. Yeah. Should we discuss this now? Ready? Should we start solving this or you need more time? Priyanka has also got 117. Guys, quickly confirm if I can proceed with the solution. Yes, Neeraj is confirmed. So let me just go ahead now, because we have very limited time left and I wish to solve a few more questions. So here we go. ABC is a right angle triangle with right angle at B. If the semicircle on AB with AB as diameter encloses an area of 81 centimeters squared, and the semicircle on BC with BC as diameter encloses an area of 36 centimeters squared, then the area of the semicircle on AC with AC as diameter will be what? So let's try it out. I think we have to draw the figure carefully as usual. ABC is a right angle triangle with right angle at B. So let's draw a right angle triangle ABC. Right angle at B. So let's say this is A, B and C. Right? So right angle at B. This is 90 degrees. Again, right angle triangle shows that the Pythagoras theorem holds true. So AC squared. The immediate reaction should be AC squared is equal to AB squared plus BC squared. You need not write this on paper, but you got to understand that this is applicable, right? AC squared equals to AB squared plus BC squared. Now read the next point here. If the semicircle on AB, see this is the side AB. If the semicircle on AB with AB as diameter, so you consider AB as the diameter and draw a semicircle. So how will it look like? Something like this. Yeah, this semicircle on AB with AB as diameter encloses an area of 81 centimeters squared. So this is 81 centimeters squared. This area is 81 centimeters square. And the semicircle on BC with BC as diameter. Semicircle on BC with BC as diameter. So I think I'm gonna run short of space here, but I mean space to draw the semicircle, but it's like this, right? Semicircle on BC with BC as diameter. So consider BC as diameter and draw a semicircle on BC. This semicircle, yeah? BC semicircle. Encloses an area of 36 centimeters square. So this is 36. Then the area of the semicircle on AC. Semicircle on AC with AC as diameter. So what will be the area of this semicircle? AC is the question. Yeah? Semicircle AC here. What will be the area of the semicircle? AC is the question. Okay? What will be the area of the semicircle? So what do we do? I think let's use this identity, right? I mean, we know that AC square equals to AB square plus BC square. AC squared equals to AB squared plus BC squared. Look at it. All AC, AB and BC are the diameters. AB is the diameter, BC is the diameter, and AC is also diameter. Yeah. So if you consider diameter, like let's say the diameter is D, what is area of a circle? Area of a circle will be equal to pi d square by 4. Pi d square by 4, right? Area of a circle is pi d square by 4, where D is the diameter. And we have observed that all these three are diameters, right? AC, AB, BC are all diameters. Yeah. So what we'll do is multiply this whole equation with pi by 4. Multiply by pi by 4. See what happens. So we get pi by 4 times of AC square equals to, this is pi by 4 times of AB squared plus pi by 4 times of BC squared. Yeah, that's the area of the circle. You're getting it? I mean, circle which is where AC is the diameter, circle where BC is the diameter, area will be pi by 4 AB square, right? So for the full circle, the area is going to be this, right? When BC is the diameter, so when you consider the full circle, the area is going to be pi by 4 BC square. But here we are talking about semicircles. Be careful, semicircle, right? It's not a full circle. It's a semicircle, half of a circle, semicircle. Yeah, all these are semicircles. So for the circle, the area is pi d square by 4. But for the semicircle, the area is how much? For the semicircle, this is area of circle. Area for circle. Area for semicircle will be, area of semicircle will be how much? Pi d square by 8 basically. So I think we should have multiplied by 8. I mean multiplied by pi by 8. Yeah, so multiply by 8. See, we are trying to get the right equation. Multiply by 8. That's it. So I know that the area of the semicircle is equal to pi AC squared by 8. Pi AC squared by 8. Because area of the circle with AC as the diameter is pi AC squared by 4. Semicircle will be half of that. So pi AC squared by 8. So this is what is required actually. Will be equal to this component. Now look at this. This is area of the semicircle. Area of the semicircle with AB as the diameter, which is equal to 81. plus this component. This is area of the semicircle with BC as the diameter, which is given as 36. Done. 81 plus 36, 170 is the final answer. So option 1, 117 centimeter square is the answer. Option 1, 117 centimeter square will be the answer. You're getting it? It's all about considering this standard Pythagoras theorem on the triangle and multiplying it by pi by 8, right? Pi by 8 because we are considering semicircles. Yeah. Similarly, if he's talking about, let's say, circles, then you have to multiply by pi by 4 only. Anyway, the answer will be sum of the two values. So if you really want a shortcut for this one, see, now that you have solved this question once, you don't have to do all this drama in the exam, right? I think in the exam, without putting pen on paper, if you remember the concept, you will say that answer is 81 plus 36. Simple. Because, you know, that's what will give us the final result. When he is asking us to find out the area of the semicircle formed on the hypotenuse, you have to be careful, right? Area of the semicircle formed on the hypotenuse. AC is the hypotenuse. So for the hypotenuse, it should be the area of the other two sides. It can be given the other way in the exam. Like for example, he may say that this is 117 on AC, on BC it is 36. He may ask you on AB. In that case, don't add 117 and 36. You will go wrong. You understand? In that case, when he's asking us to find out AB, you should realize that AC is the hypotenuse. So this hypotenuse semicircle will be sum of the other two semicircles. So this semicircle will be hypotenuse minus this one, 117 minus 36, 81. So question can be framed in a different way. Don't consider the shortcut to be simply the sum of the two values. The shortcut is not sum of the two values. The shortcut is the semicircle's area on the hypotenuse will be the sum of the other two areas, sum of the other two semicircles. Yeah? So be clear. Even if you try to take it as a shortcut, be very clear, right? Just don't blindly assume that it is always a sum. All right. So 117, option 1 is the answer to this question. Maybe, you know, just think about it once again, try it out once again yourself, and you should be very clear with the concept. And in the exam, you should be solving this in about 3 to 5 seconds. You have to learn that shortcut if you want to save time in the exam on geometry questions. Yeah. Now Sai Krishna says, initially I was thinking that the answer should be 117, but then marked it as 121. What do you mean by thinking the answer is 117, right? You should prove it. So I think the concept is that the semicircle formed on the hypotenuse will be equal to the sum of the semicircles formed on the two perpendicular sides. I mean, that statement you have to get it right and apply. Yashveer says that the questions will be like this only in the exam, but the pressure of the exam makes it difficult. Yeah. So that is the reason I'm telling you, it's not about knowledge, it's about handling that pressure. If you cannot handle the pressure, then even simple questions like this we'll not be able to solve. Yeah. So not just knowledge, your state of mind, right? Your ability to handle pressure is what is being tested. So followed, can we go for the next one? And I'm very hungry. Got it? Somebody says, बस 10 से 12 क्वेश्चंस ऐसे आ जाए एग्जाम में. हाँ, क्वेश्चंस ऐसे ही आएंगे, हमें याद रखना है कि सॉल्व कैसे करना है इनको, राइट? द शॉर्टकट और द अप्रोच शुड बी क्लियर. Amit Kumar says minus 2.5. Yeah. See, it looks to be difficult, but once you have solved it, you should know that these are all sitters. But I still appreciate those who all have used that logic of 121, right? I mean, odd one. 81 is a perfect square, 36 is a perfect square, so that also has to be a perfect square. I'm sure most of you have used that logic when you had marked 121 as the answer. All others were imperfect squares, right? All the other options, 117, 217, 221. Good thinking, but didn't help. Minus 2.5. Should we go for the next one? Murli Krishna has asked a question. Can we find out the area of the triangle using the given areas? Yes, you can find out the area of the triangle. See, you know the area of the semicircles. Can you find out the radius? Radius, you'll get the diameter. Diameter are nothing but the perpendicular sides. Once you know the perpendicular sides, can you not find out the area of a triangle? Half into base into height. Find it out. Chalo, now that he's asked this question, quickly, I'll give you like 15 seconds. All of you, find out the area of this triangle. I'm not moving to the next question. Find out the area of the triangle. or tell me if you have understood how to find out the area of the triangle. Area of the triangle can be evaluated. I know the area of the semicircle. Can I get the area, can I get the diameter? Can I get the radius? Yes. Once you've got the radius, you've got the diameter. The diameter is nothing but the side. So you'll get both the sides, the base and the height. What is the area of a right angle triangle? Half into base into height. Done. Nayan has marked 27. Mark 27 as in, yeah, he's got 27. So maybe that's the answer. I'm not sure. I'll have to do the calculation, but you should be clear that you can get it. I'll present the next question now. Yeah, good to see that Nayan, Amit, Yashveer, all of them have got 27 as the area of the triangle, I guess. Yeah. Should we go for the next one? Okay, the next question on your screens now. Try this. ABC and DEF are similar triangles such that AB by DE equals to BC by EF. Area of ABC is 16 centimeter square, area of DEF is 49 centimeter square. If BC is 2 by root 2, then what is EF equal to? So this is a standard question type again, based on a theorem that we have discussed. You just have to use that and simplify to get the answer. Quick. If you go wrong in this one, then I can conclude that you're not fit for the exam, because this is something we have discussed in the video, right? Standard. .5 root 2, which is option 2, and which is what most of you have got. Sonu Kumar, Sushant Singh, Vineet, Amit Kumar, Nayan, Milan. Good. I think 10 more seconds. I'll not ask how much time you need for this one. 10 more seconds and then we'll take up the solution. All right, here we go. Triangle ABC and triangle DEF are similar triangles such that AB by DE equals to BC by EF. The area of triangle ABC is 16 centimeter squared and the area of triangle DEF is 49 centimeter squared. If BC equals to 2 root 2, then what is EF equal to, right? So he's talking about similar triangles here, right? He says ABC and DEF are similar triangles. ABC and DEF are similar triangles such that AB by DE equals to BC by EF, BC by EF. Yeah. The area of triangle ABC is 16. Area of triangle ABC, this is 16, and that of DEF is 49. Is 49. Then if BC, this length is 2 root 2, then what is EF? This is equal to what? Now, in standard, theorem or identity that we have discussed in triangles, in similar triangles, is that, when triangle is similar, we can say BC squared by EF squared, right? Similar sides should be equal to area of triangle ABC by area of triangle, DEF. This is it. If you can use this, you'll get the answer. Or for that matter, AB squared by DE squared equals to BC squared by EF squared equals to triangle ABC, area of triangle ABC by area of triangle DEF. Use it. Yeah. So BC squared, what is BC? BC is given as 2 root 2. So 2 root 2 squared by EF squared. EF is what is required, right? EF is equal to what? So EF squared equals to area of triangle ABC 16 by area of triangle DF 49. Hold on, my pen has stopped working. Just give me a second. $49. Okay, please give me a second. Looks like this has got stuck. Sorry about this confusion. This has got stuck. Come on. Why? Uh-oh. The tablet is not working. But then proceed. I mean, whatever solution I've done so far should help you, right? So take square root on both the sides. This becomes 4 by 7. So 7 by 4. 7 by 2, 3.5 to root. 3.5 root 2, option 2. Yeah? Why is this stuck? Okay guys, I think I'll share the screen and leave that way. Let me call the technical team. Yeah, please allow us a few seconds or a few minutes, I would say. I'm not sure why is this stuck. Why? Is it muted? You know how to fix it?
Sir. Done.
Is the shade? Oh. All right, guys, I think we are back with the systems working now. Apologies for the inconvenience caused. I think I should learn how to fix this technical glitch myself, right? It can then save some time for us, right? Anyways, looks like you guys have seen the next question on the slide and you've marked the answer as 80. We'll go to that, but before that, let me quickly finish the one that we got stuck with, right? The triangles ABC and DEF are similar triangles such that AB by DE equals to BC by EF. The two areas were given and no sound. Hold on. I guess I have put the mic on. Can you guys not hear me? I see Amit's comment here saying that there's no sound. Are you able to hear me? Uh-oh, a lot of times getting killed here. Can you guys hear me? The chat also is not reacting really quick today, right? Yeah, so it looks like 80 is what you have marked for most. Most of you marked 80 as answer for the next one that you got to see when the technical team was trying to fix this machine here. And I just see Neeraj's comment here which says काश स्कूल में अच्छे से ज्योमेट्री पढ़ा होता. अब काश का तो क्या कर सकते हैं, राइट? इफ बट ये सब कुछ काम नहीं आएगा, राइट? वैसे तो काश स्कूल में सच में पढ़ा होता अच्छे से तो शायद प्रिपेयर भी नहीं करना पड़ता इन एग्जाम्स के लिए, राइट? क्योंकि जो कुछ पूछा जाता है बैंक और एसएससी एग्जाम्स में वो सब 10th स्टैंडर्ड के लेवल का ही है. सो इट्स नॉट जस्ट अबाउट ज्योमेट्री बट एवरीथिंग दैट यू डू हियर. Sound is fine, right? Yeah, sound is fine. Okay, so thank you for confirming that the audio is working fine. So what I'll do is quickly solve this one again, the one which we got stuck with, and then jump to the next one. I'm sure all of you have solved the next one as well. 80 is what you have marked. So let me present the question here and discuss the solution with you all. Okay, hold on. I'm wondering now why is the eraser not working. Erase all the ink on the slide. Why? Guys, now the pen is working, but the eraser isn't. The eraser is not working, man. Come fix it. Okay guys, you have to allow me some more time. Just a second. You're saying whatever I've written before is to be erased. Yeah, so the area of triangle ABC is 16 and the area of triangle DEF is 49. Let us now take square root on both the sides. So what do we get? We get 2 root 2 upon EF equals to 4 by 7, right? Taking square root on both the sides. And this gets cancelled twice here. So finally, the length EF will come out to be 7 by 2 times root 2. 7 by 2 times root 2. 7 by 2 is 3.5. So 3.5 root 2, option 2 has to be the answer, right? 3.5 root 2, option 2. Trust all of you have followed this. Can I jump to the next one? The question on similar triangles here. It's been solved and the answer is 3.5 root 2. So I think a simple question. You just have to remember that the there's a proportionality between the squares of the sides to the area of the triangle. Yeah. Side square by side square equal to area by area. Should we go for the next one now? All right, so the next question on your screens now. So it looks like a simple one, right? Just one line here in the question. See what it says. The ratio of angles A and B of a non-square rhombus ABCD is 4:5. Then the value of angle C is. Then the value of angle C is. Quick. Should be a simple one. Yeah. The ratio of angles A and angles A and B of a non-square rhombus ABCD is 4:5. Then the value of angle C is. I think most of you have already marked the answer to this one, right? You had got 80 as the answer. So let me solve this directly, right? So the question says the ratio of angles A and B of a non-square rhombus ABCD is 4:5. Then the value of angle C is. So there is a non-square rhombus ABCD, let's say, right? ABCD. And the ratio of angles A and angle B is 4:5. So it's, if this angle is 4x, then this angle is 5x. Yeah. He's asking us to find out the value of angle C. What is this angle is the question. Now you know that in a rhombus the opposite angles are equal, right? Angle C will be equal to angle A. Angle C will be equal to angle A. And then, you know, the sum of adjacent angles is 180. Sum of adjacent angles is 180. So basically angle A plus angle B equals 180 degrees. So basically 4x plus 5x is 180. So from this x comes out to be 20 degrees and done. If x is 20, 4x will be 80 degrees. 5x will be 100 degrees. And if A is 80 degrees, C also has to be 80 degrees because angle C is equal to angle A, so which is 80 degrees. Hence, the angle C here will be measuring 80 degrees. All right. Next question on your screens now. Try this. So what does it say? The external bisector of angle B and angle C of triangle ABC, where AB and AC extended to E and F respectively meet at point P. Then if angle BAC is 100 degrees, the measure of angle BPC is. What's the measure of angle BPC? Measure of angle BPC. Quick. $40, $50 answers have started coming in, right? Milan has got 40, Neeraj has got 50. I'll wait for more and more responses. 90 minus 100 by 2, 40. So the shortcut, Amit Kumar has used the shortcut that we had discussed in the videos, right? But is that the right answer? Got it? All right. So I think time is up. Many of you have got 40 as answer, option 3. Some of you have also got 80, option 2. And looks like a few of you have skipped. Like Mahata here says, skip. So looks like some of you have skipped it. So let's discuss this. I'm sure we have discussed this question type in our videos as well, videos of triangles. And if you remember the standard formula, you will solve this question in about 4 or 5 seconds, right? Otherwise you have to draw the figure and do the whole lot of drama. So let's solve it first using the traditional method, and then let me also explain the shortcut for this one. Okay, here we go. The question reads, the external bisector of angle B and angle C of triangle ABC, where AB and AC extended to E and F respectively, meet at point P. So basically the external bisectors of two angles, angle B and angle C of a particular triangle ABC, meet at a point P. If angle BAC equals to 100 degrees, angle BAC is 100 degrees, then what's the measure of angle BPC? If BAC is 100 degrees, then what's the measure of angle BPC? So let's consider, right? Let's consider triangle ABC. Let's say this is a triangle ABC. A, B, and C. Right? This is a triangle. Now he says the external bisectors of angle B and angle C. External bisectors of angle B and angle C, where AB and AC are extended. So AB is extended, AB is extended, and AC is also extended. These do not look like straight lines, but these are extended, right? AB and AC are extended to E and F respectively. So let's say AB is extended to E, AC is extended to F. The external bisectors of angle B and angle C. So external bisectors of these angles meet at point P. The external bisectors of B and C meet at point P. So external bisector of angle B is this. External bisector of angle A is this. These two meet at point P. This is the point P. 88. External bisectors meet at point P. Angle BAC is 100 degrees. Angle BAC is 100 degrees. This angle is 100 degrees. He's asking us to find out the measure of angle BPC. BPC. This angle BPC is equal to what is the question? Angle BPC equals to what? Now understand. Let us assume that this angle is B degrees and this angle here is C degrees. Internal angle B is B degrees, internal angle C is C degrees. In that case, what will be the external angle? See, this straight angle is 180 degrees. If you look at this straight angle, it's 180 degrees. Out of 180 degrees, B degrees is here. So what should this be? This angle should be 180 minus B. 180 degrees minus B degrees. This angle here should be 180 degrees minus C degrees. You are able to follow. B is one angle, internal angle. C is the other internal angle. Right? We are assuming those values. Then this external, see, total angle is 180. So from 180, B degrees is gone here. Remaining is 180 minus B. Similarly, this complete angle is, complete angle as in the straight angle. Let's call it straight angle, right? This straight angle is 180. C degrees is on this side. So the remaining portion should be 180 minus C. Now, since this is a bisector of the angle, BP and CP are bisectors. What will be these angles? 180 minus B by 2. What will this angle be? 180 minus C by 2. You understand? The measure of whole of angle EBC, let me write it here. Angle EBC will be equal to 180 degrees minus B degrees. Similarly, angle BCF equals to 180 degrees minus C degrees, which implies angle, you see which angle I am referring to now, angle CBP. CBP is half of this angle because it is an internal bisector, right? BP is an internal bisector. So angle CBP will be equal to half of angle EBC, which is like half of 180 degrees minus B degrees. Similarly, angle BCP will be equal to half of angle BCF. Why is it so? Because BP is also an internal bisector of angular bisector of this angle. So it will be equal to half of 180 degree minus C degrees. So basically we have got these angles. Which angles? Angle CBP, this internal angle, and angle BCP. We have to find out the angle BPC. Yeah. So in a triangle, in the triangle BPC, in the triangle BPC or BCP, we have got two of the angles. One is half of 180 minus B, the other is half of 180 minus C. The third angle has to be found. You know that sum of all the angles is 180 degrees. Yeah. But before that, let us find out what is B plus C. See, triangle ABC. Yeah, in triangle ABC, angle A plus angle B plus angle C should be equal to 180 degrees. So can I say B plus C equals to 180 minus 100. Yes or no? B plus C should be total 180 minus 100. So B plus C comes out to be 80 degrees. So just keep that in mind. Now consider the triangle BCP. What happens here in triangle BCP? We know that half of 180 minus B plus half of 180 minus C plus this angle BPC. Angle BPC equals to 180 degrees. Now simplify this. So it's like 90. 180 by 2 is 90 minus B by 2 plus 180 by 2 is 90 minus C by 2 plus angle BPC equals to 180. So if we observe 90 plus 90 and this 180 gets cancelled on both the sides. So angle BPC will be equal to what? Angle B plus angle C by 2. Angle BPC equals to B plus C by 2. What is B plus C? B plus C equals to 80. We have evaluated, right? So 80 by 2, which is equal to 40 degrees. 40 degrees is what? Option 3. Option 3, right? So that's the solution for this question. That's the traditional solution for this question. You're getting it? But if you are a smart student, you will get the answer without putting pen on paper. All this that I'm highlighting here need not be put on paper. This is a standard question type on triangles, on external bisectors of, angular bisectors of external angles. And there is a standard formula that can be used. So everything that you see in yellow here should not be put on paper, which means you can actually solve the question without writing anything on paper. You need not even draw the diagram, if you ask me. Yeah, simple. It's like a technique. I mean, shortcut formula is like a technique that you have to remember. If this angle is 100 degrees, then the angle so formed, angle P, by taking the intersection of external bisectors should be 180 minus half of this angle. You're able to follow? I mean, half of 180 minus that angle, right? Angle P, shortcut. Shortcut is what? 180 minus 100 divided by 2. Just remember this. Learn the shortcut formula and you're done. You're able to follow. That's it. So you decide whether you want to do what all is there in yellow or this simple box here, chota box. 180 minus this angle 80, half of that 40. That's your answer. Provided you remember this, you have to remember the diagram, what is happening, right? We are taking the external bisectors of the two angles, the point of intersection of those two external bisectors, and that angle has to be found when the opposite angle is given to us. We have discussed this in our videos, right? I mean, in detailed discussion. Of course, this also is a detailed solution. You don't have to follow this, right? You don't have to follow this. If you can just remember this, you'll be able to crack the question easily, right? So the final answer to this question is 40 degrees, option 3. I hope all of you follow this. It's 8:15 already. I think one last question and then we'll close the session. If you can all confirm your understanding of this one, we can move to the next one. Internal bisector will be 90 plus half of opposite angle. We will discuss all these things, right? I mean, internal bisector is 90 plus half of opposite angle. External bisectors will be, angle made by the external bisector will be 180 minus opposite angle by 2. Half of 180 minus opposite angle. These are all standard points you should remember. I mean, you cannot be wasting your precious time doing all this drama in the exam. Yeah. So is this clear to all of you? Can we jump to the next one? I think one last question before we close the session today. Yeah. Should we go for the next one? All right. So one last question and we'll meet tomorrow after that, right? For your special session on trigonometry. Here we go. The next question on your screen now. All right, so interesting one. The diagram has been given there. So I think half of the problem is solved because the diagram is already there. PBA and PDC are two secants. AD is the diameter of the circle with center O. Angle A is 35 degrees, angle P is 25 degrees. Find the measure of angle DBC. Angle DBC. This angle has to be found. I'll leave you with this for a minute or so. Let's see how many of you are able to crack this. Got it? 60, 45, 60. Okay. Amit Kumar has asked me a question, that is the angle in a semicircle 90 degrees? Well, I think your question itself is incorrect. It's not the angle in the semicircle, but the angle subtended by the diameter in the semicircle is always 90 degrees. You know, the diameter subtends an angle of 90 degrees on any point on the circle. So whether it is a semicircle or semicircle doesn't matter. I mean, whether it's a circle or semicircle doesn't matter. Angle subtended by the chord, the diameter as a chord, is always 90 degrees. Did you all get 60? Should we discuss this? Angle A equals to angle C. Multiple logics have come in there. So let me hear all the answers, right? I think different answers have come in. Durga Prasad has got 60, Mahata has got 45, Sumit Kumar has got 60, Mahata has got 60, Neeraj has got 60, Nikunj has got 60, Amit Kumar says it should be 90 in this case, Yashvir has got 60. Okay, so I think the common response, the most common response here is 60 degrees, except one which is 90. I think Amit Kumar says it's 90, but all others who have solved it have got 60 as the answer. And the fact that I've not got many responses, I will wait for a few more seconds. I'm sure many of you are still trying it out. I mean, there are like a lot of analysis that you have to do here, find out different angles to eventually get the measure of angle DBC. Angle DBC. Yeah. So let's see. Milan says he's struck. Nayan, Ajay have got 60 and 60, and I think time now to take it up. Can you all tell me what is the status at your end? If you're still trying it out, I would give you a chance. I'll give you a few more seconds. Will you guys quickly confirm your status? The last question for the session today, and then we'll meet only tomorrow at 6 p.m. to solve some questions from trigonometry. Trigonometry, which is a very easy topic. Why is it easy? Because most of the questions can be answered using the substitution method. Yeah. Okay. I think another response here, Milan, who's got 30 now. So I think 60 and 30 are the two responses. 90 also was one of them, but that's not there in the options. Shall we proceed? Okay, Nikunj just confirmed that I can proceed, so let me take this up now. Here we go. Look at the question. It says PBA and PDC are two secants. AD is the diameter of the circle with center O. Angle A is 35 degrees. Angle P is 25 degrees. Measure of angle DBC has to be found. Right? Find the measure of angle DBC. So you can see the figure is given. I mean, figure this given means what? Half of the problem is solved, because we usually spend a lot of time drawing the figure itself. Yeah. But here the figure is given. So you can see that there is a circle here where, as given in the question, PBA and PDC are two secants. PBA is one secant, PDC is the other secant. Right? These are the two secants. A line from an external point which cuts the circle at 2 points. So PBA and PDC. AD is the diameter. AD is the diameter of the circle, right? AD is the diameter of the circle with center O. So of course the center O lies somewhere here, right? On this diameter AD itself. Okay. Angle A is 35 degrees, which is marked here already. This angle is 35 degrees, and angle P is 25 degrees. Angle P is 25 degrees. This angle is 25 degrees. He's asking us to find the measure of angle DBC. DBC. Angle DBC. So basically, if you see, there is this triangle that gets formed, right? Let me connect B and D. So B and D will act like a chord to this circle, right? BD is like a chord. He's asking us to get the measure of angle, angle DBC. So this angle, basically, this angle has to be found. I think all we have to do is work on the figure itself. So I'll draw the figure again, right? I'll redraw the figure and, you know, try to make it a little bigger, enlarge it so that you can understand it easily, right? I think I can expand it even otherwise directly, but I don't know if I'll be able to write now. Yeah, I don't think I can write it. So let me just do one thing. I'll draw it myself. I mean, figure has got enlarged, but I cannot write now. Yeah, does the tool allow me to write? No, it doesn't. So I think a few points that you need to understand is, see, BD is a chord. Let me explain it to you without writing anything. BD is a chord. You know that the angle subtended by a chord at any point on the major arc is equal. So if BD is subtending angle 35 degrees at point A, it will subtend the same angle 35 degrees at the point C as well. You know, BDA is like angle subtended by the chord BD. BDC is like, again, I mean, C is the angle subtended by the chord BD. So if this is 35, this also has to be 35. So we've got this angle 35. Now if you look at the bigger triangle, BCP, you know that P is 25, this is 35. So can you get the angle B, whole of angle B? Yes. So 35 plus 25, 60. Out of 180, if these two angles are 60, angle B has to be 120. Yes or no? Angle B has to be 120. So this is 120. If this angle is 120, then this side of the angle will be 60 because this is a straight angle, right? Straight angle is 180 degrees. So this side is 120. So this has to be 60. So that angle has been found. Yeah? I hope you have understood. Angle ABC. Angle ABC comes out to be 60 degrees. Yeah? What do we do next? What can be done next? If you look at the total angle, you know, angle ABD, what we have found is ABC. ABC is 60. But what is angle ABD? Angle ABD. ABD, this angle. See, AD is like a chord, and this is the largest chord. AD is the diameter. Remember, AD is the diameter. So the angle subtended by the diameter on the circle is always 90 degrees. So by that logic, ABD is 90 degrees. What we had found earlier was ABC. ABC is 60. ABD is 90. So this total is 90, out of which this is 60, which means this angle is 30 degrees. And we are done. That's what we want, right? What's the measure of DBC? 30 degrees. It comes out to be 30 degrees. So your answer is option 4, 30 degrees. You're getting it? But I think I'll have to do it using the marking, right? I have to mark it on the pen and explain. So let me just try that. Yeah. So I'll do one thing. I have explained it already, but let me draw the figure again and explain this to you. So I'm sure the figure will not be as neat as what you see there. This doesn't look like a circle at all. Let me draw a circle. Yeah, so here's the circle. This is angle, this is the point P, one secant and the other secant. Point B, point A, point C, point D. AD is the diameter as given in the question. So center will be somewhere here, O, let's say. Yeah. Then BC is also connected. See, I'm redrawing it because so that I can explain to you easily. You don't have to do this in the exam. Yeah. This is 25 degrees. Then this is 35 degrees. Okay. Now let me tell you all that we have to do to find out the angle DBC. He's asking us to find an angle DBC. So let me draw, connect D and B. Yeah, what is this angle is the question. DBC. Now understand, DB is like a chord. Angle made by the chord at any point on the major arc is equal. So if DB or the chord BD is subtending an angle of 35 degrees at point A, it will subtend the same angle 35 degrees at point C as well. So this is 35 degrees. Yes or no? The chord BD subtended an angle of 35 degrees at point A. It will subtend the same angle 35 degrees at point C as well, because the chord at any point of the arc, I mean, even if you kind of, let's say, draw try to subtend an angle like this, this angle also will be 35 degrees, right? So a chord subtends the same angle at any point of the major arc. So this is 35 degrees. Now if you consider the bigger triangle, triangle ADP, right? This is 35, this is 25. What is the total? 60. If this total is 60, if this total is 60, this total will be, this angle will be 120. But do I need that angle? Let me see. Anyway, this angle is 120. Yeah, angle D. If this side is 120, this side will be 60. Yeah, I don't think we need that in the first place. What else can be done? See, you know that the angle subtended by AD is the diameter. Remember, AD is like a chord, which is the largest chord, right? Diameter. Angle subtended by the diameter at any point of the circle is 90 degrees, right? So can you say angle subtended by the chord AD at the point B is 90 degrees? Yes. So this complete angle is 90 degrees. You're able to follow? ABD. Angle ABD equals to 90 degrees because AD is the diameter and the diameter subtends an angle of 90 degrees at any point in the circle. Yeah. What did I do? I think we got the answer last time, right? We got this angle to be 60 degrees somehow. Let me just think about it once. Complete angle is 90. Somehow I said angle ABC is 60. How do we get ABC as 60? Oh, I am not getting that. Why did we get ABC as 60? What made us get ABC equals to 60? Yeah, that's what I had explained, right? Total is 90. This side is 60, so this side has to be 30. Okay, I think we can do this, right? See, consider this triangle COD. I don't remember what I did last time, but there's another way of doing it. Consider this triangle COD. Sum should be 180. Sum of the angle should be 180. So 60 and 35 is 95. 60 and 35 is 95. So this should be 85, right? This is 85. Yes or no? This angle is 85. Right? 35 plus 85 is 120. 120 plus 60, 180. Now, if this is 85, this also will be 85. Yeah? Opposite angles. Now, if you consider the triangle AOB, angle A is 35, right? Angle O we have found to be 85. So what should be angle B? 35 plus 85 is 120, right? So this should be 60. Angle B should be 60. Angle B as in this side of the angle should be 60. Total angle is 60. This angle will be, let me use a different color so that it doesn't look clumsy. Yeah. This angle B is 60 degrees. The total angle is 90. What are we required to find out? We are required to find out the green angle. See, there are green angle is not the green angle, but the what has been highlighted in green here, right? What will this be? This will be total angle is 90. From that subtract the red one, 60. 90 minus 60, 30 degrees. See, there are a number of ways of doing it. I mean, I am not able to recall what I did last time when I enlarged the figure to explain to you, right? But whatever you do, final answer has to be same, 30 degrees, right? So I think the answer to this question is option 4, 30 degrees, right? Angle, what are we supposed to find out? Angle DBC, right? So DBC is then this angle, 30 degrees. Option 4 will be the final answer, right? 30 degrees. So there are multiple ways of solving it. I mean, you know, number of steps may increase or decrease depending on what theorems or what concepts you're using, but you know, you have to be very quickly use different points to evaluate the angle. So option 4, 30 degrees is the final answer to this question. And with that, we come to the end of this question and also the end of this session, right? I mean, I wish we could solve more questions, but then every question from geometry is like different, right? I mean, there's no classification as such. Model level classification is not there. All you have to make sure is you learn all the theorems and concepts properly, and you should know what theorem to be used at, you know, in which question. And there can be some standard question types like what we have discussed today, right? I think 2-3 standard questions where the answer always remains the same. You just have to remember that identity, apply it properly, and get the required answer. So if geometry is your weaker section, I think your strategy should be not to solve these questions in the exam. Solve the other questions first, and if time permits, come back to these type of questions. There again, out of all the questions, I'm sure at least 2 or 3 will be standard ones where you can just mark the answer without putting pen on paper. So you got to, practice on all those questions first. Yeah. So I agree that this is not a very easy topic, not considered to be an easy topic by most of the students. Having said that, I would also mention that you can score more if you practice more and more, right? Practice is the key. The best shortcut to score more in the exam is to practice a little more than what others are doing. Yeah. So keep practicing and take very good care of yourselves. I'll see you all in the next session, which is scheduled tomorrow at 6 p.m. where we'll be discussing questions on trigonometry, right? This again is a special live session being scheduled for exclusive topics from quantitative aptitude, right? And the topic for discussion tomorrow is trigonometry. I know you have already learned the best method to solve questions from trigonometry through our videos, right? What do? Substitution. Substitute values in place of theta without violating any of the conditions given in the question. Verify which of the options for the same value of theta give us the required answer, and you're done. So we'll discuss the same concept, same technique through more and more examples tomorrow. Until then, keep practicing, and yes, take good care of yourselves. I'll see you all. Take care.